Okay, brilliant, great. Hi, everybody. Welcome to today's online panel discussion hosted by the Israel Foreign Trade Administration and our partners at the Israeli Export Institute. My name's Cameron, and I'm the trade officer responsible for the water sector here at the Israel Economic and Trade Mission in the UK. Our aim is to help foster and build Israeli ties in the United Kingdom and in turn help to promote bilateral commercial relations between the UK and Israel. I'd like to introduce Aviv, who will say a few quick words.
Thank you very much, Cameron. Just a few quick words about the event. As you may see, all of you are now on mute. If you would like to say something during the presentation or the panel, you have two options. First of all is to write it down via the chat or to raise your hand. You have an option if you click the participants button, you have an option to the right to raise hand, and then we will be able to unmute you. So these are the two options. So I'll start with an explanation about the Israel Export Institute. First of all, I would like to thank Cameron and Yariv from the Economic Mission to the UK for organizing with us this special event. Thank you very much, guys. So I'll start with a very short presentation about the Israel Export Institute, and then we'll move along. Okay, so my name is Aviv Berkovich. I am the manager of the water sector in the Israel Export Institute. We're a non-profit organization, semi-governmental, and our main goal is to do the matchmaking between the Israeli companies here in Israel and between the global players outside of Israel. Basically, we know to do, I think, the best, the matchmaking between the Israeli companies and the global players. So, like I mentioned, I'm the manager of the water sector, but besides that, the Israel Export Institute has more than 100 employees, and we have something like 20 other sectors besides the water sector or technologies. And each and every sector is supposed to help the companies in its field. So because we are a very unique organization, we basically work with everyone. First of all, we have the governmental side. I see that my presentation is a little bit stuck. Okay. So from the governmental side, we mainly work with the economic missions from the Ministry of Economy. We work together with the Foreign Affairs, Ministry of Foreign Affairs. That means with all of the Israeli embassies around the world. And with them, we do the matchmaking. We are in contact with the Israeli companies. The Ministry of Economy, together with the other ministries, are helping us to target the global players. So, of course, our job is to know by heart all the Israeli companies. Specifically, in my sector, my job is to know which company would be the perfect fit for the different organizations outside of Israel. And now it's something like 4,000 companies that we work together in the Israel Export Institute. The last pillar of our event, of the ecosystem, is the potential partners abroad. That means you guys, the water utilities. In this particular case, we will be the ones to help you to find the relevant technology for you guys. As I mentioned before, the matchmaking is all we do. We know how to connect properly those companies to your solutions. Just a little bit explanation about the water sector. We have something like more than 250 Israeli companies that are doing different technology solutions. And of course, we have many solutions from different segments. If it's desalination that we're very known about, water management, IoT solutions, water emergency, leak detection, valves and connectors, filtration. Every segment that you will mention will probably have an interesting solution for that. So that was just in a nutshell about the Israel Export Institute. This is from my side. Cameron, back to you, to the panel.
Thanks a lot, Aviv. Yeah, so how has the UK water industry changed over the past 4 months? For today's event, we are lucky enough to be joined by 5 members of the water industry. And during our discussion, we shall be talking about how the water industries in Israel and the UK have been handling the coronavirus and how technologies can help to solve some of the issues that COVID-19 has had on the water sector. Then after around 30 minutes of riveting discussion, my partner at the Export Institute, Aviv, will take over to show you some presentations from 5 Israeli water companies who will demonstrate their solutions along with the opportunity for a Q&A at the end of each presentation. We'll be organising B2B meetings throughout this week and next week, so feel free to get in touch with either myself or Aviv about scheduling a meeting. We'll send you our contact details at the end of the discussion. To begin with, I would like to introduce the economic attaché at the mission here in London, Yuriv Becker, who would like to say a few words about the event and Israel. So after you, Yuriv.
Thank you, Cameron, and thank you, Aviv, for the introduction. I'm very pleased to kick off this event today. I'm actually towards the end of my term here, and I am very happy to share another one of my finishing events with one of our speakers, Danny. I don't know if you remember Danny Lake, one of our speakers later on. We did an event when I finished my posting in Chicago 5 years ago. So it's becoming a tradition. Very excited to kick this off. You will hear a lot of about Israeli innovation in the water space. I won't steal anyone's thunder. I just want to say, as Cameron mentioned, we are here to make connections and to facilitate partnerships between Israel and the UK. Today we're getting together to do it in the water space on the innovation side. We encourage you to reach out to us afterwards if you want to hear more, if you want to learn more about any of the companies and want to engage with them. We're here to facilitate that, and would be happy to make the introductions. I want to say thank you for our speakers. We have a number of speakers from Ofwat, from water utilities in the UK and in Israel, and a number of Israeli companies. So thank you for taking the time to share with us and with the audience your insights and thoughts. I want to thank Aviv and the Export Institute for partnering up with us. And special thanks to Cameron for putting all this together and running the event today. Good luck to everyone. I look forward to a fruitful discussion.
Great, thanks, Yuriv. And let's begin with some introductions to our panelists. We'll start with the Ofwat team. Rachel and Ian, if you could give us a bit of introduction about yourselves and about the work that Ofwat are doing at the moment, and we'll go around from then onwards.
You go first.
Hi everyone, my name is Rachel Wright and I am leading on the policy aspects of our innovation fund, which we announced in December 2019. I'll say a little bit more about the fund in the panel discussion. Ian, do you want to introduce?
Yeah, can do, thank you. I'm Ian Pemberton. I'm a principal engineer with Ofwat. Been here for about 4 years after what seems like a lifetime in consulting engineering in the UK. And I have recently been working on long-term water resources strategy for the UK through a program we call RAPID. And I've now just moved across into the chief economist team to look at some of the annual reporting, but more importantly, the COVID impacts on the water industry.
Great, thanks guys. And Kieran, would you like to introduce yourself as well?
Oh. Hi to everyone. So I'm Kieran Mayer. I'm an innovation architect at Southern Water. So I've been with Severn Trent for about 29 years, most of the last 20 of those working in R&D and innovation.
Excellent. And we'll go over to the Israeli side of things. Sally and Danny, if you'd like to introduce yourselves as well, that'd be great.
Ladies first.
Thank you. My name is, you can see, Sally Levy. I'm the CEO of the water utility of Rishon LeZion. Rishon is the fourth largest city in Israel. We supply water for about 260,000 people here, not including, of course, industry and so on. Actually, the area of the municipality of Rishon LeZion is larger than Tel Aviv, which means more fights, more trouble. We supply about 21 million cubic meters of water a year, of which half of it we pump ourselves from 16 wells, and half of it we buy from the national water company Encoded. So it's another thing we have to manage on a day-to-day basis. You know, pumping water and supplying safe and pure and good water to the population is another target issue and problem. I'm here 8 years. It's very challenging, very interesting. I come from, my education comes from the water side and biochemistry. I'm probably maybe one of the only CEOs in Israel that can read a water report or sewage report. That's basically it for an introduction.
Okay, so
Danny?
Yeah, so I'm Danny. My first connection to the water sector has come from the fact that I used to play water polo for the national team in Israel. But then I went to the military. I'm a retired colonel in the Israeli IDF and combat engineering. And since I've retired from the IDF, I'm working more than a decade to the Israel Water Authority. I'm the head of the Water Security, Emergency, and Cybersecurity Division. The Israel Water Authority is kind of regulator to all water suppliers in Israel. More than 5 desalination plants, of course, national water corporations like Cellular runs, the national company Mekorot, and another more than 1,000 water suppliers, and also, of course, the desalination and, of course, the sewage system as well. We're the regulator to all those systems.
Great, thanks a lot, everyone. Let's start off with a question about COVID-19. And as we have seen, working from home has become the new normal over the past 4 months, which has been a major difficulties for companies in the UK water sector, not only for desk jobs, but for also trying to deal with water infrastructure issues too. And we'll start off with Kieran. How has Severn Trent been dealing with the current COVID-19 pandemic at the moment?
Okay, so I think the first thing was to protect the means of treating water. So I forgot to say, to give people an idea of the scale of the company, we produce 1,800 million litres of water a day, rising to 2,200 million litres in the recent hot weather we've had. So we've got about 15 large surface works, 120 borehole sites, and over 1,000 sewage works. So the first thing we did was very early on before the lockdown was to actually ring fence the operational staff and get them into as small a bubble as possible. So virtually everybody else in the company went home. So I think probably out of the 5,000 employees, about 3,000 are currently working from home. So an increased reliance on technology, video conferencing, and telemetry to get things done. The other challenge we had was some of the things like sampling, routine sampling for operational purposes and also regulatory purposes. So we worked with the regulators to agree that we could actually use fixed points on the network rather than enter customers' homes unless it's absolutely necessary. And we just started to, with agreement with the Drinking Water Inspectorate here, open that up to using sample points from our own employees. One of the biggest changes we saw was the increase in demand. So we had a very hot period I think it was in May and June, so the hottest on record, and our demand increased by over 40%. So one of the things we did was actually create some effectively emergency response teams to be ready to be called in to manage sort of incidents in that mode. And again, an increased reliance on some of the technology. So if we have to start tankering water to the ends of the system to meet demand, using sort of mobile phone-based sharing platforms bespoke to the company to help log and manage tanker activities and other elements of the incident. And again, because we saw demand increase, we've actually had to start creating new water demand models to reflect that. We saw the peak demand period change, and some of the triggers for peak demand have actually changed as well. So we noticed, the length of a dry spell, not just the temperature, is having more of an effect. I think people are at home, they're starting to pay more attention to the gardens, and also kids are at home, so paddling pools are being filled up. So a lot of activity there. But also things like during an incident when we have to deliver bottled water, we've had to add new people to our vulnerable customers list. Because if you're self-isolating, you can't go to a bottled water station and collect water if there's an emergency. So we've had to adapt our routines for that. But very, very much an increased reliance on remote data capture. And some of the things we saw recently, using drones to actually survey construction sites to be able to log it, appears to be very useful ways of not having to send people out and get in contact with large numbers of contractors on site. So lots of opportunities, and I think we're still exploring them. And almost planning for this could be the new norm for the next 3 years.
Yeah, that new normal is becoming quite worrying, I have to admit. Yeah. And Sally, from the Israeli side of things, you just heard how the UK have been handling it in that sense. How have Israeli water utilities been handling the current situation in regards to the COVID-19 pandemic?
I think that in large, pretty similar. I think the first step was to realize and recognize that we're facing a different kind of emergency than the one that we're training for and we think we know how to handle. This is a totally different emergency, which made us, we had to stop for a second and think and try and anticipate what's going to happen, because it's an epidemic. So we basically decided what are the 3 main things we would like to keep working and happening. The one most important one is the functional sequence. We do most of the things in the city ourselves with our own employees. For example, all our emergency teams are working for us. They're not outsourcing. So the first thing we did is try and put them in capsules, or what I call iron shifts. One shift does not see the other shift ever. That's how we work. We still work this way. There's a shift that starts in the morning until the afternoon. They leave, and the next shift comes 15 minutes later, and they don't see each other. And in between, they have to clean disinfect the cars or the equipment they're using, and make sure that they're not touching the same tools without disinfecting them. That was the first thing we did. The other thing is we decided that even if people are not needed at this time, we still keep the job security. We let them go on vacation, but we pay them. They're on vacation, but they get paid. So that was the other thing that we decided we keep. The other thing is that we understood that we have to supply all the equipment that people need to feel safe and be able to still work. It's masks, gloves, alcohol gel, whatever it needs, that the people know that they have it and they can use it and they need to use it. That was one aspect. The other aspect was, we were facing cyber attacks, and people are going to work at home. And of course, it needed a certain reorganization of how we have people work at home during cyber attacks, what measures do we need to take to make sure that we are cyber safe and can still work. So we got very quickly organized for that and took all the measures we need to take to be able to work at home. The other thing we had to do, and of course I'm sure everybody in the world was in the same situation, we had to close the doors. We could not have people come into not the customer service and not our own facilities. Most of us worked from home. And we kind of worked in bubbles. For example, I didn't see my secretary for about 2.5 months, except on Zoom, which was, of course, the major technology we implemented in our organization. On the other hand, we were very strict about being able to provide the best water we can, including all our means of supplying water. I mean, the wells, Mekorot, and everything, is still monitoring the water and making sure that everything is just working like nothing happens. And of course, the customer service provides all the services because we need to collect the money, otherwise how we will survive in all kinds of digital means. Even WhatsApp, we collect money on WhatsApp, can you believe it? WhatsApp to give customer service, to be able to work on customer service. We still do that. I mean, we're going back now into phase 2 of the corona. We're kind of going backwards on that. We work again on bubbles and iron shifts and capsules and all other words you can use for that. And we hope things will get better.
Great. Yeah, no, that's excellent. And from a regulator side of things, this is mainly for Danny, Rachel, and Ian. How have Ofwat, for example, been dealing with the COVID-19 pandemic? Have your aims changed? Have you taken into account different aspects, or are you sort of staying on the same path?
No, we change our perspective. I'm saying all the time that in my eyes, the world is upside down during regulation in this period of time. We focused on a few examples. The first thing that we're doing on a daily basis right now is we detect each water corporation and each water supplier in Israel on a daily basis, how many employees are operating, how many are coordinated or isolated, and God forbidden, positive for the virus. The main idea about that is to see if the water corporation can still function. The other step is to make sure, for instance, that Sally will be able to support her neighbors in times if one of the water corporations, especially on the operational side, won't be able to operate, especially in engineers and employees. So we make sure that each one can support his neighbors and so on. The other very interesting thing that is going around this few months is what we calling fake news. We have samples of fake news that was published in the press about the needs to boil the water before using them, or to do special things about water before using them. And we had to react and the press really quickly and with all our force to make sure that this is nonsense. This is kind of a new thing that we have to face in Israel during this event. I think the major issue that we are dealing in, and Sally touched it, but I would like to focus about it, is the balance between cybersecurity and the ability to operate from home or outdistance. I give you one example. Desalination plants, I forbidden them to operate their systems from distance or from home because of the danger of cybersecurity issues. I'm sure that you read in the press that we are under a cyber attack from Iran during the last period of time. So now, during the corona times, we have to make sure that on the one side, we won't get a cybersecurity efficient attack, but on the other side, if you don't have enough employees in a water corporation or in a desalination plant to operate it and to come to work, that they'll be able to operate it from distance. So that's the thing that we have to balance between those two threats, and that's the thing we're doing on a daily basis. And last is the way of thinking. I'm glad we didn't get to that point, but if we'll have a problem supplying water, how to supply alternative water under Corona virus issues, and we made few drills how to supply alternative water in these special conditions.
Excellent. And Rachel and Ian, if you could just sort of touch on what Danny was saying there, but from a UK perspective side of things. I mean, are we having to deal with fake news, or are we having to deal with, you know, cyber attacks of that sort? I assume not, but must be sort of different challenges we're facing at the same time.
From my perspective, I'm not aware of any particular rise in the level of cyber attacks. I think there's a constant threat to the UK industry. So that, to my knowledge, hasn't changed during COVID. The fundamental thing from Ofwat's perspective was we are the customer guardian. So it really was around making sure that the companies were still able to deal with their customers. Well aware that the companies have already got vulnerable registers, as Kieran was saying earlier on, and have the ability to make contact with their vulnerable customers, and then moving from that in towards sort of continuity and security of supply, making sure that in the early stages of the lockdown and the COVID, that, you know, there was business continuity. Again, through the resilience work that the companies have already done, we have a reasonably high degree of confidence that they're in a place to retain that level of service. And now we're moving into a phase of looking about what would be the short, medium, and long-term impact on the company's plans as a result of lockdown to date, and any continuity and any continuation of any restrictions that might go forward, and how they're likely to move forward, and what the likely impacts are going to be.
Brilliant, great, thanks a lot. And I think there's all some very rounded answers there in terms of how COVID-19 has impacted various companies. Sorry, Ian.
I was going to just add to that. I think that Rachel wanted to add a little bit about the potential customer impacts as well.
Apologies, Rachel, after you.
No, it's fine. I think actually Ian covered it, but maybe on a practical perspective, we also established an incident team to be able to keep in contact with the companies and understand what the implications were on a day-to-day, week-by-week basis. We were very mindful of the reducing demand on the non-household side and what that might do to cash flows and liquidity of the companies. So that was a watching brief for us. On the household side, as Ian mentioned, very conscious of the impact of affordability with people potentially out of work. The government over here has introduced some safeguards in the immediate period, but we are conscious as we move into sort of a second phase of this, what the implications are on an economic side and customers being able to afford their bills. So that's something that we're thinking about now. And then, as Ian was saying, just on the business plans, we published our final determination for companies in December 2019, and that covers a 5-year period. This is obviously the first financial year of that settlement, and we're getting a lot of communication from companies saying that actually the world is different now to what it was when you published those plans. At the moment, we're saying, well, we're sticking as it is for now. We don't have evidence as to what the world is going to look like, and it is very early for us to make any decisions on changing those 2019 decisions. And what we will do is consider those plans in the round at a later date.
Yeah, it'll be very interesting in the next few months to sort of see if your PR19 plan does sort of, you know, change or differ in any way, shape or form. So that'd be very cool to look into. Great. So the next question we sort of have is mainly based for the regulators. And in the UK, we are seeing concern regarding water shortages at the moment, especially during this summer where people will be at home, and there's a real risk that water shortage could be, you know, more long term if things aren't handled properly. And this is a question to Rachel and Ian to start off with. How has the UK been managing their water recently? Have there been vast improvements, or is there still a lot of room to work on?
Gosh, there's $1 million question, isn't it?
Had to ask it.
I think, I mean, there is always room for improvement. We, in terms of the regulation, we just remember that we are the economic regulator. So we set the levels of service that we agree with the companies, the level of service that they are going to deliver for their customers, and set the amount of money that they can recover from the customers to deliver that service. And we set that on an economic and efficient frontier. The Environment Agency in the UK set out water resource requirements for each of the companies, each of the licensed operators, and there is an expectation that they have a level of resilience and an ability to continue to deliver water during periods of sort of climate shock. So at the moment, as Kieran mentioned there, you know, the 40% increase in demand. I'm sure you'd agree that part of that was due to the fact we had an unusually warm period and a perfect storm that came together with that unusually warm period, and then everybody being at home. So, you know, from what we've seen, that the companies could manage the water resource position very well, but you then moved into a treatment and distribution capacity issue.
Interesting. And Rachel, you mentioned that you were part of the innovation fund at Ofwat. Are Ofwat now really pushing for companies to take a bigger approach to their innovation methods, or are we sort of seeing companies do that themselves without the push from Ofwat?
Yeah, absolutely. I mean, we are seeing innovation across the sector and across the value chain, but I think there is more to be done. We announced in December 2019 that we would be opening up an innovation fund, a competition whereby companies have access to £200 million of funding for innovative projects. It's a competition that's open directly to the incumbent water companies, but there's a real push, and we are incentivizing those companies to work in partnership with third parties within this sector and the value chain, but also outside of the sector, because we really recognise that collaboration is central to successful innovation. There's several areas of focus within that, and one of the things that we have asked the sector to do, the water companies themselves to do, and perhaps Kieran might want to add on this, is develop a joint innovation strategy which identifies the main challenges for the water sector here in the UK, and looks at ways in which we can meet those challenges. And the Innovation Fund, I should just stress, is one mechanism by which companies can obviously introduce innovation. There's lots of other things that are happening across UK government and independently as well. The fund is likely to open later this year, and it will be open to projects from a variety of sizes, values, focus, aims and objectives, and that's really to encourage the whole sector to get involved, not just the big companies like the one that Kieran's representing, but we have a lot of smaller companies in the UK as well, and of course there's lots of third-party innovators out there that probably want to work with us. So we're open to small, big, fresh ideas later on this year.
And Kieran, would that fund sort of be attractive to Severn Trent or other big water utility companies, and how would you sort of use it?
Yes, very, very attractive, very important. We do take part in lots of other forums for innovation and sharing. So we've got the World Water Innovation Fund, which is primarily starting to focus on leakage. We take part in Horizon 2020 projects, but we see that one as being very unique because it brings all the water companies together. There's actually a dedicated team within Severn Trent looking at that to make sure we get the best of it. And I think what I particularly like about that is its focus on testing things out and sharing the best practice and lowering that barrier to adoption. So it spreads the risk across the companies in terms of you can spend a lot of money evaluating the technology and it falls at the last hurdle. But by spreading that risk and sharing knowledge, hopefully the whole sector can move forwards jointly. Yeah, and it's really good that the smaller companies are involved as well, because we do see some fantastic things coming out of some of the smaller companies. It's not all happening in the large companies. So yeah, very exciting, interesting to see how it all plays out.
Yeah, it really is. It really is. And from an Israeli side of things, Danny, as you sort of maybe aware in the UK, there's water shortages, and we had that big heat wave, as Kieran mentioned earlier. How have Israel done so well to manage their water, for over 50 years now, considering the environment is so much more arid and so much hotter than it is in the UK?
So yeah, we have this problem or this challenge because of our climates and also because of our neighbors. It's not an easy place to deal with water, but I think on the domestic needs and drinking water side, we kind of solved the problem. We had a good winter last year, but that's not the point. We are based about 80% on the desalination plants for domestic needs water. Our main challenge today is how to supply water to agriculture, mainly with recycling water, sewage water, to sewage to water and irrigating agriculture with this kind of water. We are already 70% of agriculture comes from recycled water. But I think the main challenge that especially goes to this period of time is, first of all, is economical side. We have to kind of make in our eyes a new deal plans or innovation to make a water section works more and more and put more money in the industry that will kind of accelerate all economical in Israel. We think as that as an opportunity now to make more and more projects in Israel water section, and also in technology, the deal especially with this kind of period of time, or online detection system, communication, and the ability to operate out front. We don't have a water supply problem, but maybe it will be more efficient in this period of economical crisis. We can reduce a bit the water rates, and that's something that we can help, or at least maintain it in the same level with all the challenges we have. That's also kind of a challenge we are trying to deal with right now.
Yeah, and we're seeing so much technology come out of Israel in abundance, which of course we'll show at the end of this discussion. In terms of the host of technology that's coming through into the water sector, such as leak detection, smart water, irrigation technology, just to name a few. This is more aimed at the water utility. So Sally, how do various bits of technology meet the management of water utility companies, especially in Israel at the moment?
I'm sorry, can you please repeat the question?
Yeah, sorry. How do various bits of technology that are coming through at the moment meet the management of water utility companies?
Okay. Well, in terms of the way we run our company, we basically can run everything from far away, through the SCADA system, through other systems we use, through our transmitting water meters. We can basically run our operations without being in the offices and without being in the facilities. We have several technologies that we use to monitor storage, the level of the storage, of the storage in the ditches, to be able to prevent overflow. Since we have half of the water we supply by wells, all our wells are monitored in a way that if there's any kind of problem there, chlorine problem or other problems, the well will stop by itself, and will let us know that it's not operating anymore. So these technologies help us basically run the whole operation safely and securely. That's basically, I think, it. And of course, the way we run our cyber anti-attack system, to be able to run from far away the whole operation.
Brilliant, great. And Kieran, it was announced recently that Severn Trent released a text system. I'm right that they would notify certain areas or companies to encourage communities where spikes in water are happening. And how have technology and the new forms of technology in the water sector met the management at Severn Trent? Has it been a great success, or are you still trying to incorporate more of it?
Yeah, no, interestingly, that last one was incredibly successful. So I think there was a £1 million prize offered that will go to charities and non-NGOs in the areas that could reduce their demand the most. And I think the Birmingham reduced their demand by 18%. It was partly helped by the weather went colder, but it was incredible. Some areas reduced demand by 1%, so it's quite amazing. So that was the ability to communicate with lots of people just via the website was very useful. In terms of the day-to-day operations, we're very heavily reliant on telemetry, and as you'd expect in quite a large company, we cover, I think, 46,000 square kilometres. What we're starting to see is an increasing dependence or benefits from combining operational technologies with information technologies. So models allowing us to get much more out of the existing assets, to pick up failures before they get to a point that a motor or a particular device is going to fail. So by things like monitoring the power consumption or the vibration on it. And practical technologies such as we're in the process of developing a raw water model that predicts rainfall in the river in advance to a much higher accuracy than we've currently got. And what we've discovered is that could give us extra water during periods of dry weather. So one of our sites, we thought it actually, during a recent hot weather event, looking at historical data, gave us an extra 70 megalitres per day that we hadn't taken. But also then allowed us to manage our pumping tariffs a lot better, so freeing up the cash. And again, in investment terms, there's virtually no investment required because it's the modelling is being done in conjunction with the university. So that is proving very interesting. And one of the ways we're trying to exploit that in 720 is combining the teams that used to historically look at our IT infrastructure and innovation with software with our operational technology innovation teams. So I now look at clean water for operational technologies. I've got a colleague that works closely with me that looks at digital technologies. We find those really bridging the gap. But also, as you become increasingly reliant on remote monitoring of devices, we're seeing a benefit in having more than one way of getting the signal back. If you're reliant on mobile phones or fixed telemetry lines and there's a problem, you suddenly go blind and you have to start sending people out. So we're starting to look at things like satellite radio, fibre optics through the water pipes and the sewers is very interesting because of the things like leak detection, but also the ability to communicate with your assets in perhaps a more secure way. So yeah, an area that's developing, and we're seeing some very innovative technologies come out soon. So it's a case of finding what fits and gives us the benefits. Yeah.
Great, thanks a lot, Kieran. And yeah, thank you very much, everyone, for taking part in this. I mean, some of the main takeaways that I came up with here was the innovation fund that Ofwat are presenting is going to be a huge opportunity for water utilities to really push on with innovation and try and sort of see if we can get out of this shortage of water situation, and also trying to move forward with the UK water industry at the moment. And the idea of a new deal or water that Danny Dacca said in Israel sounds fantastic, and I think hopefully the UK government could look more into that as well. And very finally, using existing assets and adding technologies to them, as you just mentioned now, Kieran, I think is a really good way in sort of helping the UK industry to keep moving forward and to become more digital. So thanks a lot, everyone, for participating. I'll hand over to Aviv now, who will take care of the presentations.
Thank you very much, Cameron. Thank you very much to the panelists. It was very insightful. So what will happen now, we'll start with the pitching of the Israeli companies. We have 5 Israeli companies that will show you their solution. Each company will have 7 minutes of pitching and then 3 minutes of Q&A. I said during the speaking that we don't have a chat option. So my request from you guys is, if you have a question, it's mainly to the water utilities representatives. If you have a question, please raise your hand or any other reaction button that you have you can click it, and then we will unmute you if it's Cameron or I, and then you will be able to share your question in the time slot for the Q&A. So with our first company, we'll start with Utilis. The representative is Eddie Segal. He's the VP Sales and Business Development. Eddie, can you hear me?
Yes, I can hear you well, thank you.
Excellent, so please begin.
All right, cool. All right, here we are. So thank you very much, my friends from the UK. Hi, Steve, how you doing? And
Eddie, we can see the next slides as well with a manager's option. Try to see if you can.
Thank you. How do I do it? Block.
Maybe this one, no? No?
Now you see everything.
Yeah, try. Maybe if you have two screens that are connected, maybe try to unplug one.
Is it display settings at the top? Yeah.
Oh, yeah.
Okay.
Thank you very much. A little help with my friend. So, thank you very much. Thanks for your help. And as I was introduced, I am from Utilis, the company that analyzes satellite imagery to locate water underground. Now, I decided to make a slightly different presentation today than what I usually do. I'm going to tell you a secret. I will start by sharing a secret and how the technology works, how we produce valuable and actionable data for our customers in the water space by analyzing satellite imagery. So we will start by looking at the electromagnetic spectrum. And the reason that we start with the electromagnetic spectrum is because the satellite that its imagery we analyze, it carries a radar sensor, and the radars work in the electromagnetic spectrum. Now let's start from the left, okay? X-rays, discovered about 120 years ago by a physics professor by the name of Röntgen. Very short waves, very high frequency. It passes through our bodies to create image at the other side on a photographic plate, and doctors can improve their diagnosis. Now, moving to the left, we see visual light, what our eyes can see and our brains understand. And more to the left is the microwave zone. That's the area where our radar operates, but also our kitchen appliances work in the same frequency area, cellular phones, air traffic control radars. So it's quite a noisy and chaotic space. Now, the common operating principle of is that we have a source of illumination and information generated from the effect or from the reflection. Now, we will start with something that we all understand, the visual spectrum. The visual light. In the dark, we do not see colors, right? If we illuminate with a lamp or the sun, then we can see the colors reflected from the object that we are illuminating. Now, if we illuminate an area with a satellite-mounted radar, we get a picture that can be analyzed by an algorithm, similarly to how our brain can see the blue color of that table. Different shades of the gray in each pixel is directly proportional to the conductivity of the substance that the illuminating beam met on its way. This conductivity has a common name in physics called the electric constant, which is the capability of any substance to conduct electricity. For example, rocks have the electric constant of 0, whereas metals have almost infinite number. Potable water is around 80. So we can tune our algorithm to find and locate potable water, sewage, around that number by tuning the dial depending on the application that we want to apply our solution to. If we're talking about applications, let's go into more details. Leak detection. Leak detection, we have been operating in the UK for the last, I think, 3 years. Most of our of the water utilities in the UK have used or are using leak detection, satellite leak detection, some of them with even multi-annual contracts. And as I mentioned, sewage, there is no reason why we could not make a slight tuning to the algorithm and find sewage exfiltration. This solution is being tested in the UK and in other countries as we speak. And the idea is to start protecting our environment, reduce contamination. Okay, the sewage exfiltration by itself, I guess, is not that interesting. And the new kid in the block is pipes replacement decision support. There are 2 factors among several that water companies use to decide which pipe sections need to be replaced. 2 of them, as I mentioned, are missing or are not complete. For example, the age of the pipe, you know when the pipe was installed, and you know today what the age of the pipe is. However, history of leaks is something that is not complete, and corrosivity. Now, in the area of history of leaks, you can count only reported leaks and detected leaks. Background leakage, which is, I don't know, 30% of your leakage, stays out because you don't know where they are. As for corrosivity, there is direct influence by soil resistivity, which is conductivity, which is something that at the beginning of this presentation we talked about. You can use soil surveys, samplings, but it's not like actually measuring with the satellite and following due to changes in groundwater, changes due to climate change, etc., etc.
Eddie, you have only 1 minute left.
Yes, that's all I need. So, to summarize, remote can be used to reduce costs. For example, in leak detection, okay, we usually highlight about 10% of the network, so your leakage technicians need to walk only 10% of the distance to locate leaks. In the wastewater space, you can reduce contamination, as mentioned before, or prevent critical infrastructure damage. You can use more data to meet off-what targets and ODIs. And you have processes and procedures for pipes replacements, but improve those processes with new data. Now, imagine the savings and efficiency when you extract all that data from a single satellite imagery set. That's all I have to say for that. Thank you, guys.
Thank you very much, Eddie. So now we have time for questions for Eddie from Utilities. So if you guys have a question, please raise hand or any reaction button that will show you in the names, and then you'll be able to share your question. Someone would like to ask Eddie some question?
Hey, Kieran.
Yeah, hi. Oh, hi, Eddie. Thank you for your presentation. It's very interesting. It'd be interesting to understand the level of success of leak detection in a cold, wet place like the UK. Are there ways in which you can refine the detection so we can avoid false positives, perhaps due to groundwater rising and things like that?
False positives are an inherent component of any technology, of any detection technology. And even when you do it manually and you have the people miss leaks or you have dry holes. If I can tell you that using satellite technology, you can reduce your savings costs. Okay, if today to save 1 MLD costs you £500,000, with the satellite it will cost you 150,000. These are the numbers, the kind of performance that we are getting from customers. Even your neighbors sell stuff.
Excellent. Do you also offer additional data? So one of the risks we have with trunk mains that go across fields and sometimes through cities is people encroach onto the easement. So we've had people placing porta cabbing on top of the main, closing off access to a field where if there was a burst we'd need to get in. I'm just wondering if that's something that could also be done as part of a leak detection package.
Trunk mains is a big challenge. We're doing, as part of the work that we are doing with the Yorkshire Water, we provide a separate report for trunk mains. Now, when you have a point of interest in the middle of nowhere, okay, so you have a good reason to go into a private property or to look around, because there is this little bird that is telling you, hey, there is a good chance there's a leak there. So it's more focused work rather than walking the trunk mains and trying to see whether there is something or not.
Yeah. Thank you.
Okay. Thank you very much. If anybody else have questions for the companies, in the end of the session, you can stay later on and have discussion with the companies. I don't know if we mentioned it in the beginning of the event, but Cameron will send a link to the water utilities, UK water utilities, with the list of the Israeli companies, and you'll be able to one-on-one things next week with them if you see potential in their technology. Moving on to the next company, our next company is Candu. Niv Morag is the Global Sales Director. He will present the technology. Niv, can you hear us?
Yeah, I can hear you very well, and now I'm unmuted, so that's perfect. Yeah, so first of all, everybody, thank you very much. Everybody that talked up until now, a lot of interesting points. I will try to touch base also on the panel discussion that touched on the corona. And I know that we are tight with time, so I will try to run as quick as possible. So thank you very much. Again, my name is Niv Morag. I'm the sales director for Candu. So a little bit about Candu. What we understood about 10 years ago that water utilities do not know what is going on throughout their sewage network. At best, what they know is what is going on in terms of flow level at some points, But the quality of what is going on and the impact of that quality, either on its assets or the environment, is unknown until the point where it has already impacted, and that's way too late. So what we understood is that we have to understand and to see what is going on within the wastewater network or collection system, and that has to be done with quality sensors, understanding what is going on. But we also understood that it's not enough. The single parameter is telling you if the chlorine is this, or the turbidity is this, or the EC or the pH. It doesn't give you any real information, especially in this very aggressive and harsh environment. And so what we did is we put an additional layer of artificial intelligence and machine learning algorithms in order to bring real insight about what is going on in the sewage network. Our main solution is built from 4 elements. The first one is create that online map, understanding what is the quality running through the sewage network. And we do that with our own instruments. As you can see, it's built and designed with the thinking behind that it can be installed in any manhole out there. As you can see here in the picture, we have the smart data logger, we have the sensors in the sewage itself, and we have an automatic sampler. That means that once we detect an abnormality, and I'll touch in a minute about what that means, we take an automatic sample, a physical sample and evidence of what we saw of that specific abnormality, and we'll touch base on what we do with that. The second thing is putting all this information into context. So every water utility we work with, we understand what are their goals, what are their needs, what does the GIS looks like, where are the main industrial zones, where are the areas that might be most pollution-wise, and we do a risk analysis, deploy our systems throughout those points, taking into consideration that we want to achieve exactly what the water utility needs. The last thing, and that is, I would say, the main brain behind Can Do, is we gathered within the last 8 years, we have gathered a lot of information that says that we know today how different, I would say, how specific industrial discharges affect our multi-parameter sensors and the correlations between those multi-parameter sensors. That means that understanding, if I have to break it down, that a galvanic factory does not take a bucket of metals and throw it down the drain, but it's the heavy metals that go out of a galvanic factory are a part of a process. And that is what we know how to identify and source it. So detecting that type of fingerprint and understanding that that came from a galvanic factory, that might have heavy metals inside. Putting everything together into our artificial intelligence engine, which creates fingerprints, learns behaviors, recognizes trends, etc., etc. What we provide to the water utilities is, at the end, 3 main attributes. The first one is, as you see right here, we divide the city or the area of interest into basins or sorts of DMAs, and we start monitoring them. This will provide the water utility a systemic view of what is going on in terms of quality coming from each area. How much each of these areas that we are monitoring is contributing in terms of pollution. Once we identify the areas of pollution, we now can discuss it together with our clients and do the next thing, is zoom in. Zooming in, again, with the same thinking and the same methodology behind it. Understanding the GIS, understanding who is contributing to what point, we deploy our IoT units. And what this does, at the end of the day, we can identify the exact source of the pollution and provide the water utility estimated time of arrival of when it's going to hit either the wastewater treatment plant, the different pumping stations, whatever their interest of assets are, because all our systems talk to one another all the time, and with each measurement, they learn. The last thing I would say that we can provide is a complete event profiling. So if you remember, we take an automatic sample once we detect any abnormality, any different behavior that we did not expect to see at that specific location. And that sample is then being taken to lab analysis. From the lab analysis, we put it back into our system, thus creating or providing a name to that specific behavioral fingerprint. And what that does is not only being able to detect the pollution at a certain point, learn the way that it moves throughout the network itself, but also after taking that first sample, the second sample, the system will start to recognize, and it will be able to give you a more specific profile, not just that you're seeing a pollution, but hey, listen, I detected a pollution, this impactful fingerprint. The last time that we took a sample, took it to lab analysis, we had, I don't know, high amounts of COD, high amounts of ammonia, heavy metals inside. And not just that, but that specific pollution is going to arrive to your wastewater treatment plant within 3 hours, 2 hours, depending on the time.
1 minute left, Dave. Okay.
Yeah, so I'll run fast. This is just a short case study from Hera Group in Italy, Bologna, one of the bigger players in Italy. Their main problems was environmental impact, the sludge, which costs a lot of money to burn when the quality is low, and reduce the operational costs for the wastewater treatment plant. So just due to the fact that for the first time, the water utility knew exactly who is polluting and when, they had the ability to go into communication with the factories. Just on that base, we managed to reduce the COD levels, and this is only in the first 8 months, by 50%, managed to identify all the main polluters in that area, connecting directly to that reduction of the reactors OPEX by 25% and an overall decreasement of 17% in energy consumption. I'm sure that you guys can do the math alone, but that was at the end of the day what we managed to do. How was I in terms of time?
Excellent, excellent. Thank you very much, Neil. So because we don't have the chat button, I would like to adapt a different option and just to allow participants to unmute themselves. So from now on, you have the option to unmute yourself and ask the question. So any questions from Niv about the technology of Candu?
I was pausing there because I don't want to be first in with a question every time. Very interested in the ability to detect discharges from plating factories. So curious about the range of sensors you use, and also the sampler. Is it compact and also intrinsically safe, so for explosive atmospheres?
Yeah, so both AdTech's certified, and in terms of the parameter, it changes. It depends on what we're trying to find. So the parameters themselves can be pH, EC, ORP. It's always a multiple range. We have our basic parameters that we use, but these are not the parameters or the single parameters that we are talking about, if it's EC or pH, are not what's important, but what's important is the change or the impact of a certain discharge or process on those 4 parameters, and what we have gathered, how those fingerprints or what those fingerprints are telling us of what's going on upstream. I can tell you just a little bit, and coming back to the what we talked about the corona, we are utilizing right now the same methodology to detect corona residual RNA within the sewage network, understanding that also when, or in order to find the right amount of RNA and to be able to provide an insight on that, the sewage should be quite clean. And that's basically what we do. We learn the normal, detect abnormal, and not just that, but give that abnormality a name. And once you give that a name, you can understand what is going to be the impact, if it's on your aeration, your sludge, your pumping stations, et cetera, et cetera.
Mm. Also, specifically the sampling device you've got, one of the challenges we have where we want to take samples in a sewer is a lot of the stuff we've seen is quite big. It's got a manual handling risk in terms of lowering the thing in and out of the sewer. That your device looked quite compact. Either that was a big manhole.
So it's pretty compact. It's again designed and built exactly for. First of all, yes, this environment is one of the harshest environments out there. To those of you that deal with sewage, especially when it comes to industrial sewage. But we do have a couple of patents on the way that we installed on what is holding the different pipes, the location. So it's a combination of technology and methodology of work that gives us this edge to be able to detect the abnormality, take a sample, and cross-reference it with that.
Okay, excellent. Thank you.
Thank you.
We have time for one short question. Anybody else from the audience that would like to ask Niv a question?
Hi, Niv. It's Cameron here.
Hey, Cameron.
How has your technology been adopted for COVID-19 detection? I was reading on your website that you're using it to detect traces of COVID-19 in cities at the moment.
Yeah, so basically what we did, this is not an only can-do solution. We have joined with different universities from Israel and around the world. And also there, it's a combination from the academic knowledge and the possibility to detect the pathogens, et cetera, with the ability to both use our methodology of work, so detecting downstream at an endpoint, being able to take a very clean sample, let's say, that has little to none industrial discharges, which affects drastically on the residual RNA. Once we have this clean sample, and as Sally said before, it differs on right now the change of time of when those people are using the different facilities in their houses and when can we grab this sample. So once we detect that, we take it to lab analysis. Today with the technology that we have, PC, I don't remember the name, Ido maybe can help me. But the technology, using that technology in the labs, detecting the amount of residual RNA, then, all right, so we know that we are seeing an increasement. Now we're going up to the next junction. If it's a city, install 2 units, understand where are we coming from. And we do this very, very fast, being able to isolate all the way to a specific neighborhood. And this is something that we've done in Israel right now for, well, more or less from the beginning of the COVID issue. And now we're starting to work on a number of global projects.
Okay, thank you very much, Niv. We need to move forward. So our next company is Arad. We have David Sakai together with Simon, his colleague from the UK, Simon Ogden. Can you hear us, guys?
Hi. Yes, we can.
Okay. Okay, so please start your presentation.
Okay, I'll just get started. Okay, I'm just going to share my screen. Okay. Oops. Okay. Can everyone see this now? Yeah. Okay. Afternoon, I'm Simon Ogden from Arad here in the UK. So I'm just going to have a quick overview of the company profile of Arad Group. So Arad are experienced leaders in water measurement for over 75 years now. They were founded in 1941. Globally, sold in more than 50 countries with 5 operational bases. Arad are very focused on innovation with 6% of all revenues reinvested in R&D. That's 6% of turnover, not profit. Arad Group worldwide is spread everywhere from North America, South America, a couple of bases in the Europe, as well as Israel with the technology. In most of the R&D happening in Arad Technologies. We also had Arad China. So we also have a number of bases all over the world through agents and distributors. All of these places sell locally, but also sell globally as well. And as you can see from these sales here, Arad's turnover has more than doubled in the last 10 years, and that's mainly due to AMR and AMI products. We're currently doing about $240 million US per annum. So if you look at the sales by region, this is for 2018, Europe is about 12%, probably more like 14% now, Asia 6%, Central America 7%, Israel, the home market, is 20%, and the rest is going to the US with 55% of the global turnover. Arad's main focus now is on AMR and AMI. So if you go back to 2003, where meter sales were only 4% of them were with AMR, whereas when you look at today's figures in 2019, 70% of all meters that were sold were with AMR or AMI. Now you can see all the different technologies around the edges of the screen. So we've got NB-IoT, LoRaWAN, Dialog 3G, some of the proprietary systems, Sigfox. Though it's not used that much anymore, it's still supported. We believe that NB-IoT is really going to be one of the future technologies used in the UK because the infrastructure is already there, but it just needs to be upgraded. But talking to the network providers, we're getting feedback that there's never going to be 100% coverage for the NB-IoT in the UK. So for that, we're going to have to fulfill the gaps or the black holes with other technologies. So there's never going to be one technology, we don't think, that will cover all scenarios. Not economically anyhow. So what I'm going to talk about today is the LoRaWAN solution. All Arad meters are basically the same sort of solution where all the technology is underneath the glass. So in this case, this is a fully integrated LoRa meter, but the difference with LoRa compared to NB-IoT or other technologies like Sigfox is it can also be used for AMR as well as AMI. So if the network's not in place, you can still drive by and read these water meters and capture the data and alarms, etc. So the meter itself has got 17 years battery life in AMI mode, and it can go up to 27 years in AMR drive-by mode. The meter itself transmits consumptions and alarms. It also has a 4,000 point data logger internally with a fully programmable digital screen. It has full two-way communication, so we can do over-the-air activation, we can do firmware updates, so it's future-proof in the product. We can change the alarm parameters, we can ask for consumption, so we're pulling off the data log wirelessly. It has dual 128-bit AES full end-to-end encryption. The actual meter body itself is made from glass reinforced composite, which is much stronger than our traditional brass body meters. And the register itself is stainless steel, hermetically sealed to IP68. So if we look at this chart here, this gives you a kind of structure of how the LoRaWAN system can work. On the left-hand side, we have all the different products. So we have an XTR, which can be hooked up to anybody's meter. They can accept inputs such as pulse, Modbus, MBus, 4 to 20 milliamp. And then below that, we've got the Sonata, another product in the family, which is a ultrasonic water meter, where again, all the technology is under the glass within the meter. The interpreter is the same as the previous slide I was just talking about, but that interpreter can be fitted to any mechanical meter in the Arad range of water meters, but it can also be fitted to our competitors' meters, although we don't really do that in the UK, it's mainly just for the US. We have the dialog register, which is a mechanical register, but again, the radio module is inside the meter. Then we have an absolute encoder, which is again a type of universal radio module which can be connected via an encoded output. And so the different data collections we have, so we can have solar powered gateways, which aren't too great in the UK, but we do have temporary gateways that can be installed on sites. For example, we've got some sites in the UK where they're under development or construction, and what the network providers have done is put temporary gateways on the site offices during the construction until they can find a permanent location to put these gateways. The meters can also be drive-by from day one and all the way through their life, and you can just read the meters via drive-by. Now, once everything goes back to the LoRaWAN cloud, it can then go to third-party systems or third-party billing systems, analytics, or it can go to our IoT servers and then go into our MDM Harmony. And from there, it can also go to any other third-party system. The other thing to add is that they have these meters, all these devices have a BLE Bluetooth chip inside them, so we can actually connect to the meters via a mobile phone application. There you can send it straight back to the MDM, our Harmony system, or we can use it for installation services like capturing serial numbers, location details, photos, etc. The other thing we've got in the XTR family after our experience in the UK and in the US is we've got a pit booster, which basically can be connected to the water meter and brings the signal right to the surface, so greatly increases signal propagation. We also have the wall mount version, which will be connected to large commercial meters, other bulk meters, and DMA meters for water balances, etc.
Simon, 1 minute left.
Okay. Okay, the last thing to say about the LoRaWAN is just the alarms. We've got low battery, backflow, tamper, leak, freeze points. Again, with the data logger built inside. We have certification for RAT and MID, and it's suitable for the UK boundary boxes because of the fact that we haven't got any additional devices or cables or clip-ons. It fits in all the chambers that we use in the UK. We have done a lot of testing, but we found that this system can work even at a depth of 1 meter. However, the signal strength is dramatically decreased down to less than 100 meters. We tested at 65 meters with a good signal, but then in the other scenario, when you get the meter closer to the surface, where it's only 10 centimeters below the surface, we got 1.8 kilometers. And this was with the gateways installed at very low levels. So you can see the issues that we have in the UK and the different solutions we have to just try and overcome them. So thank you for your time. That's it. Thank you.
Thank you very much, Simon. Any questions from the audience to Simon about Arad's solution?
Yeah, no, it looks very, very interesting technology. It's certainly an area we're starting to look at. The frost point is the first time I'd come across that in a meter. That's quite an interesting idea, as well as things like continual flow. Does that allow you to warn the water companies where there could be bursts breaking out in localized areas due to the cold weather?
Yes, because if it's on a fixed network, it can send out an alert straight away. So the water company becomes alerted to the fact that it's getting close to a freezing point down in the boundary box. And we have found this in some water companies where they've got metal lids where gaps in them, the cold at certain times actually drops into the bottom of the boundary box and can freeze the actual concentric meters. So I think it could be a useful alert.
That's true, yeah. Are these in use sort of widely outside Israel? You mentioned the States as well?
Yeah, in the States, they have very similar installations to us in the States, so we can share the types of technology and the different solutions we come up with because of them having the water meters below ground. In Israel, they're all above ground, so it's very easy to set up a wireless network. Yeah. But in the UK, it's a completely different scenario.
Yeah. Okay, thank you.
Okay.
Any other questions for Simon?
Just sorry, one last question. The battery life looked incredible. Particularly in AMR mode, 27 years. Is there significantly different battery, or is it just low power consumption on the meter?
It's a significantly different battery. In the past, because we've got a mechanical register, you only have a little bit of room inside the meter when it's integrated to have a battery pack. Whereas now the electronic digital registers, they have a big space underneath to put a C-cell battery. And even the add-on devices, we can put a D-cell battery. So you've got maybe 4 times the capacity in the battery. So there you get the longer lifetime.
Okay. And at the end of the lifetime, just send the meter back and...
Yeah, you just send the meter back. Just a direct replacement, yeah. Okay. Trouble in the UK is you can't just take things apart and put them back in because of regulation on the domestic supplies. The meter has to be tested and certified before it can be put in the ground.
Yeah. Thank you.
Okay.
Thank you very much. I encourage everyone to ask questions. If you haven't had the chance to ask questions with the previous companies, Don't forget that at the end of the event, we'll have also time for like 5 minutes of Q&A to all of the companies. So please stay tuned. Our fourth company is Takadu. Dan Bar-Lev, the Global Sales Director, will explain about the technology. Dan, can you hear us?
Yes, hi.
Hi. The floor is
Good.
yours.
Thank you. Good afternoon, everyone. I hope you can see my screen.
Yes, perfect.
So in the next 7 minutes, I would like to go over what we see the water sector challenges, the Takadu offering, and the way our solution addresses these challenges. A little bit about the Takadu installed base, the deployment process of our solution, the experience for our customers in the first year, and the customer reference. So when we speak about common challenges, we see the water losses as the most common one, and this includes, of course, both the physical and the apparent losses. And next to this is the operational efficiency that focus on the back office employees' efficiency, prioritize dispatching of field teams, the cost of leak detection and repair. And in terms of customer service, it's around improving the customer satisfaction through reducing outages and improving the quality of service. Digital transformation is about what we call the data tsunami, with the ever-growing sources and systems producing data these days. And regulatory compliance is around water quality, pressure, and NRW goals. Knowledge loss is about, of course, the issue of aging workforce. So what does a central event management mean? Takadu collects the data from meters that monitor the network operations, such as flow, pressure, water level, PRV, and water quality meters. These meters are spread all over the network, and utilities collect this data centrally in one or more data sources. The solution then converts the data into knowledge by analyzing this data and detecting of anomalies that imply on leaks and other asset malfunctions. So beyond the event detection, Takadu is a platform to manage the life cycle of events, supporting an effective decision-making, eliminating silos between departments, and forming a centralized dashboard for information from other solutions. So how does the leak detection work? We receive the data in our cloud every hour, and the data resolution is 15 minutes. Then the system automatically learns the behavior of the water supply in each DMA, cleans outlier values, create predictions, and complements short data gaps. Next, the system is checking for anomalies by matching the actual received data with the historic and network predictions, and searching for slow developing leaks. When an anomaly is significant in terms of time and magnitude, the system declares about it as an event, and the entire cycle from receiving the data until event was declared takes only 1 hour. The system operates continuously, and this way Takadu is monitoring the network 24/7. So this is an anecdote for the Corona time. We try to show that even in a time of change, the Takadu systems knows how to smartly select the right prediction and avoid raising false events. So based on analyzing the history records, one may think that there is a problem since the actual flow is significantly lower than the anticipated flow in the DMA. However, by analyzing the water supply in similar DMAs, the system recognizes that the actual water supply is totally normal. and avoid raising a redundant flow decrease event. So Takadu detects automatically multiple types of events beyond leaks, such as pressure issues, meter problems, faulty meters, missing meters, DMA breach, different types of events. And in our roadmap, we are also in the process of developing events around pumps operation in the wastewater. So as a central event management, Takadu integrates with additional systems, and the information from these systems complements the event detection of Takadu. For example, through the integration with IBM Maximo, we present work orders that are related to activities of the utility in the DMA. So this is how a typical event looks like in the Takadu system. As a platform that allows the user to detect and manage the whole cycle of the event. We can see here in one screen the event type, its magnitude, the duration of the event, when the event has started and ended, the status of the event, who is this event assigned to, last comment. We can see down here, the actual value or the actual data received from the network versus the prediction. We can see here the map of the DMA and additional assets that provide information. These are all in one screen. And as to show the maturity of Takadu, this is a partial list of customers of Takadu from around the world. We operate in 12 countries around the world, from Australia to Latin America, North America, Europe. Some of these customers go with Takadu for the last 10 years since the company was established and exercise multi-year agreements. So although Takadu is a sophisticated solution, the deployment takes only 2 months, 8 weeks, and the system is live. And this is a proven methodology that works for dozens of our customers from around the world. Our cloud-based software solution requires no local installation and minimal IT resources.
Done, 1 minute left. Okay.
Okay, wonderful. So the value utilities experience along the first year using Takadu is developing. It starts from understanding the functionality of the system, visibility and transparency into the network, detection of prediction-based events, continue with collaboration between departments, bridging over the silos, adapting new work processes, rolling out to additional areas, and deploying of new models of the Takadu system. So as mentioned, this is a reference of an Australian customer that have seen a great value since deploying Takadu. Tangible values that you can see here, from 9 billion liters of water loss avoided in the first 2 years, 66% reduction in repair cycle, and 10 times return on the ROI. These are all from this customer, and we have many like this. So this is it. Thank you for your time, and if you have any questions.
Thank you very much, Dan. Any questions from the audience to Dan about Takadu?
Just one question about it. It's a very rapid setup. So you're saying you don't need people to come into the water company's office. You can actually do this remotely via the cloud?
Exactly, exactly. And we see this, especially in these days that nobody is traveling, and we can do everything from remote. Of course, if we could, we would travel, and we used to do this, but these days we do it remotely.
That's fantastic. Also, in terms of the visibility of the system across an organisation, do you have a limited number of users, or is it a sort of a dashboard that you can share widely?
Well, it really depends. It can be a couple of users, it can be tens or sometimes more. It really depends on the commercial agreement between us and the customer.
Okay, so it's very, very flexible. Yeah.
Very flexible.
Thank you.
You're welcome.
Okay, thank you very much. So we'll move to the last but not least company, Jeroen Locker. He's the CEO of Miltel. He will explain about Miltel. Jeroen, please. Yeah.
Thank you, everyone.
We can't hear you properly. Can you hear us?
Yes, I can.
Okay, please raise your voice a little bit.
Okay. Good afternoon. Thank you for joining us. Is there an echo?
A little bit.
1 second. Here we go. I hope this is better. Thank you for joining us today for a presentation describing Miltel's utility IoT solutions for monitoring and measuring. My name is Jeroen, just as Aviv just mentioned, and Miltel actually has been in this area for more than 20 years. We have more than 2 million AMI installations, but we took this one step further, and being the last speaker actually gives me an advantage because I can relate to some of the things mentioned just during the things that Kieran mentioned, and also Sally and some of my colleagues such as Neve and Simon and Dan. I just wrote down a few words: communicating with assets, remote monitoring, remote data acquisition, telemetry, monitoring of facilities, SCADA. All of that ties in. We actually try to fill in the gaps and take this to the next step. So everyone knows that once you're able to measure, what you really want to know is to collect that data and bring it back at the lowest possible cost. It's common today. I mean, in the past, utilities knew, telemetry and SCADA are not new systems, but in today's utility, SCADA and metering are taking a new direction. Utility IoT is becoming a reality by, just like in the domestic world where people are connecting almost everything to a device that collects that information. Also the utility world, we see that by using a combination of RF and cellular technologies, we're able to collect information at a very low cost of data acquisition, bringing the information back from almost any outdoor environment or even indoors. I mean, depending where we are around the world, and I'll give a few examples. We're in basements, we're in pits underneath the ground, we're inside buildings, inside metal cabinets, almost everywhere. And the challenge is, I think like Simon mentioned earlier, it depends where your gateway is, depends where your device is installed. So by moving into the cellular world, actually the network already exists, and it's not only narrowband IoT, it's a combination of all the LTE technologies that are already available and moving on also to 5G. Miltel provides the utility company with technologies for at least 3 different areas or areas of operational applications. We start off with AMR, just like many other of our colleagues, and we collect information from any type of meter or a sensing device which collects consumption data. We provide the full solution, not only including the telemetry technology, but also the software that helps analyze all of that. So we actually fit in very well between the different companies that is presented earlier, and we do have some cooperation with some of the companies that were mentioned. I'll give some examples later. The second area is sensor metrics. Any other type of sensor which you could collect information from, whether it's analog or digital, pressure monitoring, level of sewage in a pit, and I'll explain the difference between when we speak about sewage, about monitoring the quality and getting early alerts for events such as level within a manhole, temperature logging, acoustic leak detection, together with a partner that we help them collect the information, and other applications in the area of asset management, because at the end of the day, the utility has hundreds, if not thousands of assets, some of them remote sites, some of them equipment out in the field, and everything today, once you're able to monitor, you're able to react when something happens. I think that concept flows very directly through the presentations of all of my colleagues before me. So it's very clear that once you know the information, you collect it, you're able to manage it, you have a much better position to react, to lower your operational costs, and to react to events when they happen. Obviously, we use, as I mentioned earlier, RF technology for fixed networks, but recently we've introduced units or devices based on LTE, including Cat1, Cat-M, and narrowband IoT. So the basic cellular endpoint, maybe because we've seen so many manholes and pits in the previous presentations, we know that it's very difficult to get a signal out of an embedded device. We've installed more than 2 million units. Out of them, at least half of them are integral, like the meters that you've seen in the previous presentations. But we know that once you're in a very difficult situation, harsh conditions, being able to cope with that, being able to get the signal to get out of a water meter pit or a sewage manhole is quite a challenge. So we developed a device which is able to work in very extreme conditions. Last winter, there was a big storm in the US and we had dozens of units like this operate for a week in temperatures of -30, -25 Celsius for a few days in a row. And now I'm not only talking about logging the information, but sending the information out daily in such harsh conditions. So that's just one example of what we really need to cope with. Obviously, the main challenge is being very small, being battery operated for years. 10 years is a standard. As mentioned earlier, there are devices that we have in the field also. We have experience with some units that are already 15 and 20 years in the field with RF, and with cellular, reaching the same numbers already now, depending on the application, of course. And we have the ability to connect to the same device, either the integrated internal antenna or an external antenna. In the basic metering applications, what this actually means is that we can collect, whether it's daily, hourly readings or quarter-hourly readings, and send that information once a day or several times per day. When the installer puts in the device, he could program using a Bluetooth phone application, program the device and set the parameters. That doesn't mean that later the utility can send the signal and change the definitions. So if the reading is collected originally for most of the customers once per hour, later at a later time, you could take that information or take that and change that for a specific customer if there's a need to collect that information more frequently. Obviously, all types of events are detected at the level of the endpoint. So it's not only about analytics at the high level of the system, but also at the endpoint itself. So we're able to send immediate alerts for tamper, for leak detection, whether it's a slow leak or fast leak. We have customers with typically 100 to 200 events per day that they notify the consumers once they have a leak, even if it's a running toilet or if it's a leak in the irrigation system.
Yeroem, 1 minute left.
Okay, thank you. Other applications include, well, before the other applications, maybe I should just give one short example for what we're able to do at the data level. Just this is an example of an NRW analysis for DMAs. What you can see here is the lower line, this chart, which is the cumulative consumption of all the residential meters. At the same time here, this is the bulk meter in that DMA. You can see by this pattern immediately that there's a leak in this area. And once that leak was fixed, you can see at this point over here that now there's another leak hiding behind the back of the first leak. You can see that easily that this is not theft or water sabotage or other unmetered accounts. Just a few other examples of devices that we connect to our equipment. We can measure pressure monitoring using the same device. We can connect this to sewage floats that give us an early alarm once the sewer level rises before we get a overflow. And we can actually connect this to many other asset management sensors using the same technology and displaying the information on the same portal. We also have connected this to leak detection sensors using a third-party equipment, devices, and using their algorithms, we're able to use the same cellular technology to convey that information. To summarize all of this, what we actually bring to the utility is a very low-cost device that can connect to almost any analog or digital sensor and fill in the picture and move the data into our information systems or partner with other companies that have technologies for analyzing this data. I'd be glad if anyone has questions.
Sorry, I just realised I got myself on mute there. Sorry, the last point you're saying, you've got your own sort of analytics monitoring platform, but you can also send that to third-party analytics if required?
Correct. The BI system itself gathers the information, archives it, provides tools for exporting it, whether into standard files or APIs into other systems. In the past, we had cooperation with Takadu, for example, Aquarius Spectrum, and other systems that have analytic tools. So we provide two levels. The first level is our own BI built into our system, and the second level is communicating and integrating with other systems, whether it's, first of all, ERP, CRM, and other web-based systems. And obviously, if they're analytical systems, we serve as a funnel for moving data from the sensors all the way to the top-level IT systems.
I was going to say a couple of other questions. I guess first one on the leakage analysis. I like the example of the finding the primary leak and then picking up the secondary leak. Is that analysis automatic, or does somebody need to review each sort of graph manually?
Okay, there are a few different tools built into the BI system, into what we call data sense consumption management system. The basic tool is that, first of all, you can put in your DMAs or DMZs. So you have to be able to have the quality of the data, of the information that you start off with, has to be to such a level that you have the consumption meters and then the bulk meters or the district meters, so you're able to analyze the data. Then once you have that set up, and we have a lot of experience, we have probably hundreds of utilities that we work with. Once you have that set up, then we can provide automatic reports. You define for each DMA, you define which level of leak you allow. Once you go beyond that level, you get an alert from the system, or you could handle a daily or weekly analysis. Part of what we do when we handle the AMR level of it, or AMI, we take snapshots of all the meters within the district, within a DMA, at midnight and at 5 a.m. Once you're able to synchronize, if the system is a time synchronized system and not just a randomly transmitting, you can take a snapshot of all the meters within the DMA at the same fraction of a second. And then you could run at a 5-hour difference between midnight and 5 a.m. You could capture a lot of valuable data, and then the alerts start jumping up automatically. On top of that, obviously, the system gives you tools that you can sit down and analyze afterwards, because at the end, you're running investigations. When an event happens, then you start digging in, and then you can see much more data then. That example is actually from Brazil. It's a real town. It's a neighborhood within a town.
Okay, thank you. I forgot time to ask another question. I'm conscious on a lot of time here. One of the things a lot of the water companies in the UK saw was an increase in blockages during the restrictions, partly because all the toilet rolls disappeared from the supermarkets and people put in other things down. So your sewer level system looked quite interesting, very, very straightforward, just a floating probe. Is that a sort of fairly low cost system to install?
Yes, correct. That's part of the concept. We're not replacing the other technologies demonstrated or described earlier. It's a complementary system. What's nice about it, that it's very low cost. And actually, we had some customers asked about sensors that give the exact level, but we saw that adding cost by taking more expensive sensors actually works in the opposite direction. We've had a town here in Israel where their infrastructure is, I would say, very old. They had manholes that are very shallow. And I mean, I've been to the UK, I've seen what happens. There are areas where the infrastructure still needs a lot of improvement. And when you go into areas where the manholes are very shallow, you want to be able to react within, I would say, 10, 15, 20 minutes from when the fluid level or the sewage level starts rising. So that town, they detected, or they did a little bit of homework, and they defined, I think it was about 60 or 70 manholes, that every month they have at least one event of a overflow. And they went and installed these sensors, very low cost, into these manholes. and they actually connected the alert directly to the truck guy that goes and pumps them out. So he reacts immediately. Even, I mean, the fact that the utility has the notice, they don't wait for that notice. They want to react within, I would say, less than half an hour with the guys on the site. So yes, that's part of the concept, being able to provide a solution which is low cost both on the sensor side and on the communication side, with the very little infrastructure, of course.
Okay.
Thank you very much for the both of you. So before we finish this session, I want to leave like 1 minute or 2 minutes for the participants to ask questions if they didn't have any time to ask the other companies. So this is the time to ask questions to the other companies, or military as well. So anybody else with a question? If so, please unmute yourself and ask. Okay, so what will happen next? We're gonna wrap up this session. Just for you to know that we recorded all of this session, so you will be able to get the recording of that and to overview it. Besides that, if you would like to have a one-on-one meeting, virtual meeting with the companies, Cameron, my colleague, will send you the list of the companies, and you'll be able to schedule with the companies the one-on-one meetings. Thank you very much, and Cameron, passing on the torch to you.
Yeah, no, everyone, thank you so much for joining. It was a fascinating discussion we had at the start, and some really interesting technologies which I think could work really well in the UK. As Aviv just mentioned, feel free to get in touch with either myself or Aviv. We'll send out an email to everyone who participated with our contact details, and also with website links to the companies that presented. So thanks very much. We hope to do it again soon. And yeah, have a great rest of your day.
Thank you.
Thank you very much. Bye,
Thank you very
everyone.
much.
Bye.
Thank you.